So let's go ahead and start fracturing these pieces now. So to do that, we're going to run a for each named primitive on this. Okay, let's connect that up and maybe go to single pass so we can see one piece, which we don't see for some reason. Let me just check. Oh, so we don't want that running on the name. We want it running on the class attributes. There we go. So we can see one piece here. And with this, you can see that many of the pieces, well, this piece, in fact, is planar, right? So we've got, it's open geometry. We can see the back of the polygons there, and some of the pieces are not. So we need a way, we need to treat them differently. So I'm going to drop a group node here. There's not many pieces which are watertight, but there are some, and it's a good way just to it's a good thing to just understand how to separate them anyway. So what I'm going to do is turn this to points. I'm going to call this planar. Right, check this include by edges and unshared edges. Okay, and turn off the base group. There we go. And now you can see what it does is make a selection of the points which are on an open edge. Okay, and so if we have 3D geometry, if I just put like a box into this, which is not, let's do that, and it doesn't have the class attributes. I'll just quickly let's do it like that. You can see there now with this box, as this is watertight 3D geometry, I'm not selecting any points, right? The group is empty. Okay, but as soon as maybe if I delete a part of this, just do that, you can see those these points are selected. Okay, so let's go to the box, plug that back in. Okay, but the problem is here, I want the value to be the same on all of the points here, right? So I need to do some kind of play with the attributes to have a one value for everything. So at the moment I've got a group on some of the points on my piece, right? So what I'm going to do is generate an attribute from that first. I'll just do attribute wrangle and call this, so I'm just going to have an integer, call this planar and set it to 1. Okay, I think we did something similar in another lesson, I don't remember. And then I'm going to promote, so attribute, yeah, I think in the first week we did it actually. Attribute promote, and I'm going to take the planar attribute and make it detail. So if you remember, detail will be one value for the entire piece of geometry, and make sure we set this to maximum. Okay, so each point there will have a value of 0 or 1, right, which is set up here. And what we're doing is taking all of those values and looking at the maximum number of all of them, which is 1, and setting one attribute to the entire object, and that will be set to that maximum value, which is 1. Okay, so now I have one thing for all of this. And as we go through each piece, when we find a piece which has, when this group is empty, then this attribute will be, I need to set this to the planar group as well, actually. Otherwise, this just sets 1 to everything regardless of this group, okay? So when we have 3D geometry, we don't, everything will be 0, and here the maximum will be 0, and it will be set to 0 on everything, right? So what we could do now is do another attribute promote just to bring it onto our points again. Bring it from from detail back to point. Okay, and I think we need to set this to maximum also, and planar. Okay, and then maybe just to take a look, just to visualize this, let's do red at planar is 1, And then hopefully when I go to the end, turn off single pass. Okay, not working yet. Seems to, let's see. Maybe this doesn't want to be on maximum. There we go. Set this to points. Go to the end. Okay, and you can see here we've got just a couple of pieces which are 3D, you know, they're not planar geometry, and the rest is. Okay, so once we have that, I'll just get rid of that. So set this back to a single pass, come up here, and what I'm going to do is drop a split. Okay, maybe let me name these. Creates planar attrib. Let's see there. And that's fine. We can see what we're doing. And split planar is what we're going to do here. Okay, we don't be careful here because you don't want to just select the planar group because that's these points, right? In fact, maybe we should just delete that group here because we don't need it. Group delete. And here. Planar. Cool. And then we want to use the attribute. So we do at planar is 1. Okay, right, I've lost my piece. At planar is 1. I should be able to see it still. Oh, maybe I have to specify. There we go again. Yeah, I have to tell it that it's a points group. Cool. So we got our flat piece there. So for RBD, yeah, we don't want planar geometry. We need 3D, you know, watertight geometry. So what I'm going to do, there's a few things you could do. You could, you know, create a VDB from this, or I don't know, create spheres. You know, there's lots of different options. But I'm just going to poly extrude these. I just found that that worked in this case for myself, for me, right? So I'm going to extrude this. Make sure to always check output back. Okay. And I'm going to raise the distance a bit, and then we can see it going up. Obviously, that's way too thick. I'm going to do 0.5 like that. Okay, so we get a bit of a kind of chunky thing, but what's important is that we've got 3D geometry now. Then we can reduce this a little bit. I'm going to set this to points normal. I prefer the, yeah, XD, that's a bit better. I'm going to probably reduce this down a bit. Do 50%. Okay, save us some memory. Okay, and then one thing that's happened now is we don't have the same attributes all over because we've generated new new geometry. I'm going to do an attribute. Where is it? Oh, transfer. I want attribute transfer. There we go. Okay, and I'm going to copy it from here. What I want to copy is the that class attribute that we generated before, because that's not going to be on the new extruded side, right? So that should be fine as it is now. If I just take a look here quickly, in the class we've got the value there everywhere. I think if I turn this off, you can see we got zeros there. So that's good. And then obviously we want to fracture this now. Okay, so I'm just going to use the standard Voronoi fracture. So we need to make points from this. Let me click this into the bottom here. So we'll make some points. Yeah, we don't want to use force total count because we've got different size pieces. Obviously, you don't want 1,000 pieces on a tiny piece and 1,000 on a giant piece. You know, you'll just get very uneven fractures. So we use a density scale. I'm going to set this to 500 and relax iterations. Push this up to 55. Okay, so that we have quite even pieces, and then what I'm also going to do is actually fuse these together, which will even them out a bit more. Okay, so any that are really close together will be fused. I'm going to do this to 0.05. So you can see it's quite coarse, the fracture that I'm doing. I don't want it to be really, really flexible and bendy. You know, I want the metal to be quite stiff, and the smaller your pieces are, the more flexible your metal is going to be, right? So it's something you can play around with. You know, it's quite an important value. This density scale, you know, will affect your fracture quite a bit, your simulation quite a bit, right? So Voronoi fracture, drop this in there, this on this side. We should see fracture geometry if we visualize the pieces. Maybe, oh, we need to turn this on and make sure, yeah, we got name attribute on there. Great, let's call it bendy. Okay, and that's pretty much it for this side. And then obviously we need to do something similar on this side. So I'm going to copy this. So we want to also scatter to anything that comes out over here. The same values. I'm going to also poly reduce anything that comes in there. Okay. But you know, we don't need to poly extrude it basically. And then I want the fuse as well. Basically the same, but without the poly extrude. And we don't need to attribute transfer because we're not generating any new geometry. And then we'll grab the Voronoi fracture, geometry in the left, points into the right. Okay, and then that's all good. And then we'll merge these together. Just like that. Connect up at the bottom, and then let's clean up what we've got. Attribute delete. Okay, and I'm going to delete that. Where is it? We come down here, we plane our attributes, and then that's all we've got. We can keep all of those. Okay, come to the bottom, turn off single pass and let that run through. Great. So you can see we've got the car all fractured up there. I'm not worried about taking these the constraints from here. We're going to build them later on. We could just do a quick exploded view. Just to take a look at that, make sure that everything's working correctly, and you know, seems fine. So you can see there, yeah, the kind of density of what we're doing in terms of the fracture. You can experiment and you know, try increasing or decreasing even the amount of geometry there. And obviously this is not going to be the final, just like before, whenever we do metal bending, we're not going to be rendering this geometry. We're going to use the deformations that we generate with this to point deform the original render mesh, which won't be poly extruded, right? We'll have the original planar geometry.